Okay, Assalamualaikum warahmatullahi wabarakatuh and very good day. Okay, now for this part we will discuss about the property tables for the compressed liquid, or sometimes we call subcooled liquid state of origin. Okay, so if you look at TV diagram and also PV diagram, so the temperature for the condition of the for the state of compressed liquid will be lower than saturated temperature at a given pressure, as shown in the TV diagram. And also we will have specific volume value for that state. At this state, in terms of phase, for example, in this schematic diagram shows the piston cylinder device. So the substance inside the cylinder will be compressed liquid, which is equal to the phase will be 100% liquid. So the region that involved is this kind of state is we call compressed liquid. However, if we refer to the PV diagram, in terms of criteria or condition for the compressed liquid, the pressure given must be greater than the value of P saturated, or saturated pressure at constant temperature. Okay, at constant temperature. So the intersection point will be between the horizontal line for the given pressure and also the constant temperature line, and the intersection will be within the compressed liquid region, and also we will have specific properties for that point or state. Okay, so the region is compressed liquid. So now for the compressed liquid table, so this is the example for the compressed liquid table for the water. Okay, so the minimum pressure for this table is 5 megapascal. So in the bracket with red color numbers represent the saturated temperature. So if you look at the column, temperature column, set SAT in red represent the value in the bracket, which is 263.99 degrees Celsius. So the value will be changed depend on the pressure of the compressed liquid. For example, if the data are not available, for example, for the compressed liquid region, when the pressure below than 5 megapascal, for example, so we need to make assumption because we don't have data for the compressed liquid. So we need to make the closest assumption, where for the compressed liquid the phase is 100%. So the closest assumption is the compressed liquid we can assume as saturated liquid, because for the saturated liquid state, still the phase is 100% liquid, which is almost similar with the condition or the phase for the compressed liquid. But now we need to refer at the given temperature, because the compressed liquid properties depend more on temperature compared to the pressure. Okay, so when we make assumption, we need to refer to the temperature. Okay, we need to base on the temperature in order to obtain the value for the what I call the assumption value for the compressed liquid. Okay, so if you look at TV diagram, so this is the point for the assumption, where we assume that the phase is saturated liquid, but at the same temperature. Okay, similar goes to PV diagram. So the temperature will be constant, so that's why the point must be located on the constant temperature line, and the state is saturated liquid as shown in the PV diagram. So now for the assumption, all the properties such as specific volume, internal energy, enthalpy, and also entropy for the compressed liquid state that we assume as saturated liquid. So we need to refer to the value that which is Y equal to YF at specific temperature. So Y represent the value of V, the specific volume, internal energy, enthalpy, and also entropy. So when we make assumption, the value of the specific properties for the compressed liquid will be assumed as the specific properties at saturated liquid. For example, the value of U for the compressed liquid after we make assumption will be equal to UF. For the specific volume will be VF. So for the enthalpy will be HF, and for the entropy will be SF. So this is for the case where we make assumption, where the data of the compressed liquid is not available. Okay. So for the assumption case, the table that we need to refer is saturated mixture table based on temperature, because we have two type of table for saturated mixture table. First we have temperature based, and also the second one we have pressure based. For the case of assumption, so we need to refer saturated liquid vapor mixture table based on temperature. For example, this is the saturated water table based on the temperature. So we need to refer to the temperature, and the value for the specific thermodynamic properties, we need to refer to the what we call the properties for the saturated liquid state. Okay, so if we refer to the value of V, so we need to refer to VF at specific temperature. For U, UF at specific temperature. For H, so we need to refer to the HF value at specific temperature. And the last one, for the entropy, we need to refer to the SF at specific temperature. Okay, so in terms of characteristic, how to determine whether the state involved or within the compressed liquid region or not. So these are the characteristic or the criteria, where the temperature given must be less than T saturated at given pressure. The pressure given must be higher than P saturated at given temperature. Specific volume must be less than VF at given pressure and temperature. The internal energy value must be less than UF at given pressure and also temperature. For enthalpy, also the enthalpy value must be less than HF at given pressure and also temperature. The last one is the value of entropy, where the value of entropy for the state must be less than the value of SF at given pressure and also temperature. Okay, so by using this criteria, we can use this criteria to determine the whether the phase or region within the compressed liquid or subcooled liquid phase or not. Okay, example 3.8, determine the internal energy of a water at 5 megapascal and also 80 degrees Celsius. So data given: substance water, temperature 80 degrees Celsius, pressure 5 megapascal or equal to 5000 kilopascal. So phase, we need to determine the phase of the condition. So when we want to determine the phase, we need to refer to the saturated table. So now for this case, we need to refer to the saturated water table based on pressure, so we can obtain directly the data. Okay, this is the saturated water table based on pressure, where for the pressure of 5 megapascal or 5000 kilopascal, the saturated temperature will be 263.99 degrees Celsius. So compare the temperature given in the equation with the value of T saturated at 5 megapascal or 5000 kilopascal value. So the temperature given in terms of value is less than T saturated at 5 megapascal or 5000 kilopascal. So the phase is compressed liquid. Okay, if we plot on the TV diagram, so we just draw the constant pressure of 5000 kilopascal or 5 megapascal, and the saturated temperature is equal to 263.99 degrees Celsius. And we just draw the horizontal line for the temperature of 80 degrees Celsius, and the intersection with the constant pressure line will be within this within the compressed liquid region. That's how we can determine the phase for the specific state for the compressed liquid region. Okay, so internal energy value, so we need to refer to the compressed liquid water table, so we can obtain directly. So because the pressure is 5 megapascal, so we can get the data from the table. Okay, so at 5 megapascal and temperature 80 degrees Celsius. So in order to use the compressed liquid table, at least you need to have two data or two information. Okay, so for this case, we already have the pressure and the temperature. So from the table, we can determine the value of U, internal energy, where U equal to 333.8 kilojoule per kg. Okay, as stated in the table. Okay, so now as an alternative, let's say if the data for 5 megapascal is not available for the compressed liquid phase. Okay, so what you need to do, you need to assume that the compressed liquid as saturated liquid at given temperature. Okay, so the temperature given is 80 degrees Celsius, so you need to use temperature, and then you need to refer to the saturated liquid condition. Okay, so now because we already make assumption, so we need to refer to the saturated water table based on temperature. So probably we can obtain direct information from the table. Okay, this is the saturated water table on temperature table at 80 degrees Celsius. The value of U must be referred to the value of UF because we assume the state as saturated liquid. Okay, so the internal energy U to UF at 80 degrees Celsius equal to 334.86 kJ per kg. Okay, so if we look the difference between these two methods in terms of error, let's say, so the error is below than 1%. So the assumption method for this case is acceptable. Okay, so in case the temperature is not 80 degrees Celsius, so probably you need to make interpolation instead of direct data obtained from the table. Okay, now is the summary involved with the different type of property table that we have learned before. Okay, so property table actually will use to determine the pure substance properties such as the temperature, the pressure, the specific volume, internal energy, enthalpy, and also the entropy. First, in order to use the properties table, so we need to determine the phase for the specific condition first. Okay, and in order to determine the phase, you need to use the saturated table by using the comparison between T saturated, P saturated, X value, VF, VG, HF, HG, UF, UG, SF, SG with the data given. Okay, so you can use all this information from the saturated table with the data given, and also you can use the TV diagram or PV diagram in order to determine what called the phase of the state. Okay, first criteria: if the temperature lower than T saturated, the pressure given higher than P saturated, and the value of V lower than VF, U lower than UF, H lower than HF, and S lower than SF, so the phase will be compressed liquid. And then after confirm the phase, for this case the phase is compressed liquid, then you need to refer to the compressed liquid table, okay, in order to obtain the actual data for the specific thermodynamic properties. Okay, so as I mentioned before, for the compressed liquid, if the data is not available, so you need to make assumption. Okay, your assumption will be the compressed liquid is equal to the saturated liquid, and then you need to refer to the saturated table in order to obtain the data for the assumption. Okay, so at least you need to have two data or two information in order to get the data from the compressed liquid table. Okay, so if the temperature is equal to T saturated and pressure equal to P saturated, and V is between VF and also VG, U is between UF and also UG, H between HF and also HG, S between SF and also SG, so the phase will be in saturated mixture region. Okay, so the table that you need to refer to is the saturated table. Okay, so for saturated liquid phase, for example, so you need to refer to the properties that involve with F, UF, VF, HF, SF. For the saturated vapor state, you need to refer to the properties involved with VG, HG, UG, SG. However, if the state involved is mixture, So you cannot directly obtain what I call the value of U, H, V, and also S. So you need to use the specific formula, as we already discussed before. You need to calculate the value of quality and so on. Okay. Also, at least for the saturated table, you need to have one data or one info. And the third condition or characteristic, that if the temperature given greater than T saturated, pressure given lower than P saturated, and V specific volume greater than Vg, U greater than Ug, H greater than Hg, and S greater than Sg, so the phase will be superheated vapor. So now you need to refer to the superheated vapor table. At least you need to have two data or two info in order to use the table to obtain the specific thermodynamic properties. That's the summary for the property table. Okay, now this is the your exercise 3.1. So determine the missing properties and the phase description in the following table for water. Okay, so in terms of table, you need to refer to the table for the water. So you need to fill in the data in the table. For example, for question A, you need to determine the temperature, internal energy, and also the phase. Okay, so you need to use the what I call the principle or the method that I explained before in previous slide in order to determine the missing properties in the table. Okay, so you can use also you can use the TV diagram, PV diagram in order to obtain the data and so on, to determine the phase and so on. Okay, I will let you to get the data, okay, to try to fill in and try to implement whatever method that I already teach you, explain to you in previous slide. Okay, to in order to fill in the table. Okay, that's all for this part. Okay, maybe we will discuss the answer in during our live discussion. Okay, on the next class.